So I want you guys to ask me or tell me specifically maybe what topics have been troubling you first.
C 1 through 10. The first test. I can't remember any of it.
Okay, some of the stuff we did for the first test.
Like the imaginary number?
Okay. So some of the basic stuff about imaginary numbers that you should know. First of all, one good part is this, the discriminant. Remember b squared minus 4ac? Okay,
Oh,
this
yeah,
thing that was under the radical?
Yeah.
What's that thing called? B plus or minus the
Negative b plus or minus the square, yeah. If this thing, remember, if this discriminant, because this is where it comes from, like that, that's what you're talking about, Jay?
Yeah.
If this discriminant value is negative, okay, you have imaginary roots. That's one instance where you can use imaginary things, okay? And remember from graphing techniques, imaginary roots, you don't see them on the graph. It would be an example like this. If you had a parabola that was floating, right? You don't see the cross the x-axis. Well, what are the roots? The roots are imaginary. That's one use of it. You don't have to write this down. It's a recording, so you can watch it again later if you want.
Bootcamp leaders are now meeting in room 204.
Other stuff.
Bootcamp leaders are now meeting in room 204.
Like this. Remember this kind of a problem? How do you divide those two?
Yeah.
So,
Isn't it just a subtraction?
isn't this again?
Is it a subtraction?
What do you mean?
Like, you know how when we did the exponents, when it was like a division sign, it meant subtraction and stuff like that?
Yeah.
It's like, is it like that?
It's not like that for this now. For this, you have to multiply by what was called the complex conjugate. Like that.
Yeah.
Okay, so remember the bottom is minus 4i, so we make them both plus 4i. The reason we did that, because now we can FOIL this. The top, when you FOIL it, you have 2 times 1 is 2. Outer gives me 8i. Inner gives me 3i. And last gives me 12i squared. Okay, that's what we did for this part. On the bottom, though, the cool part is that when you do this, the FOIL, what happens? Anybody remember?
Cancel out.
Yeah, the middle terms cancel out. So the first term, you're going to get a 1. In the outer, you're going to get plus 4i. Inner, you're going to get minus 4i. And then last, you're going to get minus 16i squared. But look at the middle terms. They drop off. That's why this technique is useful. And now, what was I squared? Remember that?
Negative 1.
Why? You're right.
Because of the chart thing.
Yeah, good. So remember, I to the 0 is 1. I to the 1 is I. I second is negative 1. I to the third was negative I. We did the I wheel. Okay? So the thing you need to remember really is this one here. This is the important one. Okay? So since I squared is negative 1, I can replace this with a negative 1. Replace this with a negative 1. So the top becomes 2 plus 11i in the middle, combining these 2 to 11. This is going to be minus 12 now. Okay, why is it minus 12? Because it's a plus, and we have the negative and the positive 12 there. On the bottom, we're going to end up with just this 1. This is going to be a minus, which is a positive 16. Thus, in the end, take a look. Do you have any I in the denominator anymore?
No.
It's gone. That's the whole idea. Get rid of that I. Okay? So, as an answer, 2 minus 12 is negative 10, plus 11i all over 17. So this, right here, this green part we started with, ends up be looking like that. There's no I left in the denominator.
Now, when do you know when the number is imaginary?
If the square root is negative. So for example, if I asked you to say, if I said, what is the square root of negative 36? You bring it to negative 1 and positive 36. Square root of 36 is just 6. The square root of negative 1 is I.
Oh, okay.
So by default, this is just 6i.
Are there going to be a lot of problems in tests with imaginary numbers?
They didn't go into too much detail in their test with imaginary numbers, not at all.
What was it that they went into detail with?
Okay, lines. So, remember this? A is the slope, and B is the...
Oh my god.
That's,
That's the. Isn't that where you start?
Yeah, which is called the
No, y-axis.
y-intercept. Close. It's your starting point, your y-intercept. Okay? So if you had a graph, and the graph was just given to you like this, and you were asked, you have 4 choices. This line can be Good, sorry. And the question says, which of the following choices could be that line? Could. No numbers are given besides that. Which answer choice would you pick? Why B, Mia?
Because it's for the y, and it's the axis.
Good, so you know it's got to be a 5 here, right? We all saw that? So this one's out. How do you know it's not C or D, though?
Because it's,
Oh, because.
it's not negative. It's not
Yeah, no,
down.
good. It's going up, isn't it? So what kind of a slope do you have to have?
Positive.
Positive. These are negative, aren't they, both these slopes?
Yeah.
Since they're both negative, these are out automatically. So the only answer that would make sense would be B. Okay? So knowing the idea of a line, knowing that the slope is the constant in the front, knowing that the y-intercept is the last thing. Similarly, which I talked about in the last class, so you can watch the video from Thursday, I'm not going to go into much detail here, but similarly, we look at quadratics the same way. This is the y-intercept, remember? And this tells us if it's concave up, or opens up, or concave down, opens down. So those are important parts. But I did a lot of quadratics in Thursday. So if you want help on quadratics, go back to Thursday's video and look at that. Okay? Let's see, other stuff, like vertical shifting, horizontal shifting, stuff like that. Remembering that if you have a function like y equals, let's say, g of x, and then that's y1, and y2 is g of x plus 1. What's the difference in these two graphs?
An extra.
Yeah, but what does that plus 1 at the end do to it?
Moves it up one
How
space.
far?
One space.
Good. Now what about this, Jason? What if I had this? Like that now. What's the difference there?
It adds one value to the x. So what do you make it like the slope difference?
Close. Does add a value to the x in that sense. That's right. Yeah, it moves it horizontally. Remember, the thing on the end is k, right? This is like your h. So this would be up 1 from the original. This would be left 1. Because remember, what do you do when it's on the inside? When it's the h value, you do the you do the opposite, okay? Remember, whenever it's the h value, whatever occurs in here, you think of the opposite. So normally plus 1, you think go with the right one. But it's left 1. Plus 1 up here does mean go up 1. So these are just your general transformations. Okay? Why are you standing? Take a seat, relax. Ask a question.
I have a question about a concept. I think it was concept 21 with the domain and range ones, where it was like there was a whole, where we go.
It was in Thursday's video. You didn't watch the video yet?
No.
Yeah. Eddie asked the same question. Eddie Romero asked that, and I put it in the video on Thursday. Can you look at that one for that answer? We went into a lot of examples. I'm not going to do it again. We just did it already. So you're going to see on news, there's a video for Thursday. Okay, the first thing in the news, you'll see Thursday review video 1 to 2 p.m. Click on that, and I went over domain and range there.
What's everything
Right?
going on?
Yeah.
In the other review sessions, it was like domain and range, parabolas. We did some stuff with growth and decay, the recent stuff we had done. Probably those 3, maybe one more topic additionally. Yeah. Anybody have specific concerns? Or I can just come up with some problems right now.
Yeah.
Yeah.
Besides like graphics, like as in general, like,
Okay.
I was doing my test.
Let me, before you guys, let me just give you a little extra knowledge about this. There's no graphing on the test for you to actually graph. The CRM test does not make you graph anything. I think there's one graph for a whole thing. Everything else is like matching graphs. So they'll give you a graph, and I'll say which of the following choices matches up with this. Or they'll give you a graph and say which of the equations represents the graph shown to the right. So a lot of this stuff, you can just go to your calculator and plug it in, look at the graph on the calculator and match it up. You're welcome to do that. Nobody's stopping you from it. You have to have a calculator, obviously, to do that. But actually graphing, like you sitting there and graphing, I'm pretty sure. Yeah, there's literally one question on graphing, and it's graphing 2 lines. That's all it is. Like graphing lines on graph. There's no graphing by hand at all. I don't know if that helps before you have a question, but did you have a question? Go ahead. That's all right. Okay.
My second question is, like, remember when we were doing, I don't know, concept, it was between concept 10 and concept 15. Something like that, but,
Linear functions? Is that 10 and 15?
we had like an H, and then parentheses Y, and then like, it had like a 2, and then parentheses, and then
Oh, compositions?
wait, is it function?
Function compositions?
bottom.
Domain and range, function,
Yeah, compositions.
So like I knew how to do it at one point.
Okay, let's do an example then. If you have, let's say you have g of x equals 2 radical x plus 5, okay? And f of x equals x squared minus 7. And the problem says, what is f of g of 4? Like that, Mia? Okay.
Oh.
So you always work the inside out, right? Inside out. So see the 4 is in the inside there? You take the 4, you plug it into g. That's what it's telling you to do first. So you plug a 4 in here. What's 4 plus 5? 9. What's the square root of 9?
3.
What's 3 times 2? So when you plug this in, you get 6, right? You take that answer. What do you do with it? I'm recording this, Mia, so if you miss anything, you could always watch the recording. When you take the 6, what do you do with it next? Yeah, into which one? Good. You go to the next one. So you go over to f. You plug the 6 in. 6 squared is 36. 36 minus 7 is going to give you 29. That's your answer. So you work your way out, inner to outer. Okay? That's a good question. That's definitely on there.
With
Systems? Yeah, covered Thursday. Sorry, that was definitely on Thursday. I know for a fact because I said I was telling people to use a matrix if they'd like to. It's definitely on the video. So he's talking about systems of equations with substitution method, elimination method, matrix method, where we had the word problems and stuff, and X, Y, Z, you have to solve for the variables. That I covered that on Thursday, so look at the video for that.
One question on that. Can you use the matrix for all of those?
Absolutely. I mean, if it says a part 2 and it says solve by hand, you should probably show your work by hand, but you can always check on a matrix. But if it's a part 1 with multiple choice, I highly suggest you just use a matrix. Don't do it by hand, it takes more time, right? You learn the matrix for that reason. Bridget and then Rosie.
Can we do an example of transformation?
Okay. Specifically, what kind of function? Generally or any
Not like this actually, but like
up and down, shifting left and right, that kind of stuff? For what kind of functions? Like parabolas, curves, what? Any function?
like things like that.
Oh, so any function at all.
Yeah,
That
like-
was any given function. All right, so let's say you have a graph and it looks like the following. Like that, Bridget? Anything at all? Okay. I'm going to put some data points on there. And let's say this graph is represented by the function g of x. And then you're told that f of x is defined as g of x minus 2 plus 3. Something like that. And you're asked to plot, let's say, plot f of x. Okay, in red we'll plot it. What does the plus 3 mean again? Which way? Up. Very good. So vertical is the word there. Vertical. What does the 2 represent? Which shift? Horizontal. Which way though?
To the right.
To the right, because you do the opposite. So remember, this is to the right, and this is up. So for this kind of a problem, if you're trying to find the graph that matches, so they might give you a problem like this, right? And then say which of the 4 choices would represent the transformed graph or the translated graph. Your answer choice would have to be something 3 units up and 2 units to the right. So take all of your points, go up 3 and over 2, put a point. Up 3 over 2, put a point. Up 3 over 2, up 3 over 2. See what I'm doing? It looks a little bit messy, I know that. So if you connect these now, and I'll use a black dash line here, this is what the graph would look like now. That would go there, and this would drop down with the same slope as this one, and this would curve up like this, and it would curve down into that one. So then it's going to curve back up, and it's going to curve back down to here as my little trough, or my bottom of the curve, and it's going to come back up to there. So I know it's tough to see, but here's the beginning, right here, and here's the end, right here. And the graph goes pretty much through these points like that, into there, up, and over. And the graph that you're seeing there is the exact same graph as the green one. It's just been shifted to the right and shifted up. So a lot of these kinds of problems, you're going to be asking, or they're going to ask you, what happens to the graph of a function like this? Right 2, up 3. Or which graph matches the newly transformed function? You got to find which one looks like it, but it's been moved over and up. Okay, that's the extent that you're going to get for transformations there. If this number had been, if it had been a negative sign, what does that mean? You have to do everything.
Move it down.
Not move it down.
You just flip the
Left.
center.
Switch it, center all the time.
He was closest, but you're off by a little bit. You're right with the switch and stuff.
Do it flip.
Yeah, which way though would it flip?
Like that one.
No, like down.
That's fine. Because remember, guys, f of x is really y, right? So they're saying now that y is equal to the opposite of all the other y's. Well, aren't all these y's, aren't they like above the axis for the most part? So which way would they flip? The y values below the axis. So this whole thing would be the same shape, but on the other side down below. Okay, so you would literally reflect it over the x-axis if you saw a negative sign there. Because this is negating all of your y values in a sense. Okay, and it would have to look like this, by the way. Okay, for that to make sense like that. All right? We're good on basic exponent rules, guys? Like, for example, something like this. Now, let's say, like that. What would this answer look like? I know it's very basic.
X minus something.
Okay, now how would I write that, though, if I didn't see that as a choice?
1 over X.
Thank you, John. Very good. Okay, remember that whenever you have a negative exponent, you make it 1 over the positive exponent. Let's see.
Did you do, permutation?
Is it on the test? We didn't cover it yet. Let me see if they're covering permutation combinations though at all. I have a feeling they didn't do that on here. I mean, I know I did it because it was on your SAT, so you'd be prepared for that. But no, permutation combinations are not on here.
Did it have probability?
Okay, probability is not on here.
So that's what I was gonna ask you, so is it like all the concept,
It could be any concept in Algebra 2, it's just that they don't have the same curriculum that I use.
I mean like the concepts, specific for us, concepts from 67, no one with ACT problems, they're all not gonna be on?
They're not on here, no. I can tell you that right now just by looking at this. What if we had a problem like this? Okay. Something, it just looks complicated, right? It looks like a lot of stuff. Just what would you do in general? Give me a strategy here.
Just
Good. Like terms right away. So first of all, you see that you have x's all over the place, right? How many x's do you have up top altogether? Be careful. 4. How come? And? Thank you. How many down below? 3, right? So your answer should have how many x's left over? If you cancel.
1
Where?
on the top.
On the top. Again, there's 4. Everybody see that there's 4 here up top
Oh, yeah.
and 3 down below? So automatically start canceling your variables first. Make this problem easier on you. What about your other variable? 5 up top and how many below? So how many are left? Where?
On top.
Now the numbers you can take into account. Because a lot of students, you know what they do? They distribute the square to all the numbers. If there had been parentheses around this like that, then you have to distribute the square to both, right? And that becomes a 4 over here. But there's no parentheses, so please be careful with that. Okay, now look at all your numbers, start combining. So let's say, if you have a calculator, you can just simply multiply across the top, multiply across the bottom, and find a common denominator or lowest terms. Or you can cancel stuff. I don't know if there's much to cancel with this kind of a setup, though. I should have made this number like, how about that? 35 over 7, or 35 over 5? 7. So whenever what I'm trying to explain is that when you have an instance that you can cancel earlier, do so. So here, 35 divided by 5 is 7. Reduce that to 7 over 1, just to make the work easier on you later on. Okay, now up top, you've got 2 times 7 is 14. 14 times 2 is 28. On the bottom, you've got 3 times 1 times 11. That's just 33. Can you reduce 28 over 33?
No.
So you leave it at that point. But whenever you can reduce initially, do it, and then make it easier. If you can't reduce anything, like earlier, I had a 34 there. You couldn't reduce it. You just simply multiply across the top, put your number here, multiply across the bottom, put your number here, and then try to reduce. Hold on, I'm going to stay on this for a second. Let's see. Have a new question?
Yeah.
1 second, okay? Another way to check, and a lot of people forget this, if you want to check if something can be reduced, just put it in your calculator always.
Right.
So if I want to know that 4/8 can be reduced to 1/2, we all know this, right? I hit 4/8, I hit math, convert to fraction, and just hit enter. It puts in lowest terms. So like earlier, we had 28 over 33, right? And I said, can that be converted to a lower fraction? You all said no. Hit math, enter, enter, and you're correct. It can't be reduced any further. So this is a good technique to always use to reduce the lowest terms in case you forget. Back to John.
With the Quistory network exam, I understand like the way they ask us the question is different. With you, I knew it was like challenges and you always made it like, it was straightforward. But since you said the Quistory network was supposed to be easier, is it gonna be like straightforward?
Their multiple choice are pretty straightforward. Like they'll give you an equation, say find the roots. So you're finding the roots. I mean, you guys all have the program in your calculator, right?
Yeah.
So I hope you use it. Like use that stuff.
I bought mine, so I kind of.
So hang out, get somebody else's act, and we'll do it. Make sure you don't leave without doing it.
YouTube, that's why
You got it? Did you go use the link I put up, or you found it somewhere else?
I didn't Google it or
Good.
off your site,
Very
because I
good.
didn't put my calculators at math class, so they didn't put it in before.
And you watch them program and you just
Yeah,
replicate
it
it?
took like 10, 15
Yeah,
minutes.
but it takes about 6 seconds to transfer if somebody else has it, so I'm happy to help you if you'd like, but you could do that. That's what I encourage you to do whenever you need stuff like that. Yeah, the questions they ask are pretty straightforward, guys. They're not meant to be tricky, especially the multiple choice. The part twos have a little bit more complexity to them, but really not too much.
How much?
I expect like 80s and above from almost everybody in junior class in this test. I'm not saying it's easy at all. No, but seriously, guys, I'm not joking. If you study and do your work, it shouldn't be hard. It's easier than my test. It really is. Okay? You have to say, can't just not say.
That's what Miss Jenkins said, I didn't know anything on that test.
I think you'll be surprisingly happy.
Same thing with history, with all this.
History was
not-
no, history was
good.
What would be the hardest
It was
one?
easy.
Most people
The
do
thing
all.
with chemistry is they word it differently.
I know they weren't top.
That's what I meant to, like,
So what
wording
would be
the
the
word
hardest thing
differently,
on
though, the way you thought.
Alright, for example, guys. For example, there's a problem on here where they ask you, they give you a matrix, they say find the matrix squared. We never went over that. Like, we didn't talk about how to do that. But if you put the matrix in your calculator and then just press the matrix, like for example, okay, just so you're not lost tomorrow when you see this. If you had a matrix that said 3, 1, 4, 7, okay, matrix A was represented by 3, 1, 4, 7. And it said, what is the value of A squared? Like that. Well, we didn't do this. It doesn't work. You can't just square each term or anything like that. But it does. We didn't do this in class, right? So you know what you do? You go here and you type in, what did I say, 3, 1, 4, 7?
Yeah.
So I go to my matrix. I go to second matrix. I go over to edit, and this is the 2 by 2. So I'm at 2 by 2. So I get the 2 by 2. 3, 1, 4, 7. 3, 1, 4, 7. Okay. So the matrix is loaded. Second quit. Let me clear out. I pull out my matrix again. I pull out matrix A, and I square it. I hit enter, and that's the answer. There's no need for you guys, and I know we didn't cover this, and that's fine. You're going to do more with matrices when you get to pre-calculus and like an algebra and stuff. But it's not. There's no need for you to know how to do this by hand. And that's what checking really. But you can use your calculator. You're allowed to use it on the test. So if you want to figure out what a matrix squared is, because a lot of you are going to be like tomorrow, or people are going to be like, we never learned this. I understand that, but you got to use intuitive thought. If you know how to put a matrix in a calculator, and it just asks you to find that matrix squared, simply go ahead and put it squared.
That's the actual question.
Okay? There's different numbers and stuff, but it's pretty much no different. You know what I'm saying? Okay, so again, you can't just square it. Like 3 squared is not 13. This is not 3, 1, 4, 7 all squared. See that? And that's what the common mistake is on here for sure. They put the square of each of them and put it on there, so people will take that. You understand what I'm saying?
Oh,
Okay, so it helps to be here right now, because other people might not know that. Again, if you were to find the roots of a function, let's say the function looked like this. Okay, who's got their calculator with them? Give me the roots. Use your program, give me the roots, tell me what you get.
I don't have that.
I have it, I don't know.
So go to your program, and then you should see roots on there, or program, whatever you called it. Hit enter, it's going to ask you for ABC. 0.5n, negative 4. Oh, that worked out so nicely. I didn't want it to work out nicely. That's what the roots turn out to be?
Yeah.
Change this to a 3 and see what happens. I want it to work out very messy.
Change what to?
Change the last one to negative 3. You want, that's the right 3, 6, enter. Now it's going to for A, B, and C. So plug in 2, 7, negative 3. Okay, perfect. That's what I want. All right. So Mia, read them to me. 0.38.
.3860.
Okay.
0.03.
And
Okay. Negative 3.
negative,
3.886.
like that? Okay. Now, everybody see those roots you got? Remember the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. When you do the quadratic formula for this, here's what you're going to get. And I'm going to show you the difference here. Watch. You're going to get negative 7 plus or minus the square root of 49. 4 times 2 is 8 times 3 is 24. And 24, 53, 73 all over 4. Okay? So, take a look at the answer I get this way. And take a look at the answer you guys got on the calculator. You see the difference? Now, they're the same numbers though. They're the exact same numbers. But on the exam, if they said find the roots of this function, the multiple choice answer you want to pick is this one. So do you see how the roots help you, but they kind of don't? So what could you do in this kind of a problem to check which answer is right? Karina? Yeah, evaluate this. Not solve for, but evaluate. Exactly right. Exactly. Do negative 7 plus radical 73 all over 4. Or do negative 7 minus radical 73 all over 4. And what you'll get are these two answers right here. Is everybody clear on that? So you're going to get decimals if you use your roots program, even though their answer choices are given in radical form, because they expect you to use the quadratic formula. But if you didn't want to use the quadratic form, which you don't have to, you could try all 4 choices and see which of the 4 choices matches up with your roots. Okay? So go ahead and type in, like, anybody. Juliet, I see you have a calculator. Negative 7 plus radical 73. Okay, hit enter, and then press divide by 4. You should get the 386 something? Yep. So when you do that with the positive root, you're going to get this. If you type in negative 7 minus radical 73 all over 4, you're going to get this as an answer. Okay, so in the case that you do the root program and your answer doesn't seem to show up, you might have to check the answer choices to see which one it is. All right, let's do another one. What about this? What if I asked you to find the domain of radical 2x plus 5? Okay, so say the function was f of x equals, f of x equals radical 2x plus 5, and you want the domain. What does domain mean, first of all? Which values?
Infinite x.
X values, thank you, the x values. It could go to infinity, we know that it could, but I'm asking which values is the x coordinate. So I can do this 2 ways. One way to do this is to go to my calculator and just graph it. And when you graph this, okay, what you're going to notice is the graph is going to look something like this. Okay? And this is going to be a certain value. This is going to be, by the way, it's going to be 1. So let me erase this because that's not correct. Down. That's going to be like a 2. That's going to be a 3. So you're going to see.
Kelly Escamilla, please report to Mr. Blanco's office. Kelly Escamilla, please report to Mr. Blanco's office.
You're going to see that the function starts somewhere between negative 2 and negative 3. Okay? And it goes to the right. So the domain for this problem is everything to the right of that, right? Again, it starts at negative 2 point something. Well, I want to know what that value is. So you can also do it by hand. Take a look. What can't the radical be? What do we know?
0.
In general, what can you not have underneath the radical?
Negative.
A negative. Because it makes it what? Imaginary. You can't grab something that's imaginary. So you do this. Why? Why greater than or equal to 0?
Because 1 and 2 are 0.
Or 0 itself. Again, greater than or equal to 0 is the key here. So you move the 5 over, right? You get negative 5 here by subtracting 5. How do you get rid of the 2? So x is greater than or equal to negative 2.5. Again, I move the 5 over by subtracting 5. Subtract 5 from both sides, and then divide by 2, divide by 2. So you know already that this coordinate here, that's what they're talking about. That's that value. So your answer for this problem is right here. That's it. Or you can write it in interval notation, from negative 2.5 to infinity. And notice, why did I put a bracket next to negative 2.5? What does the bracket indicate?
Included.
Yes, it's included in the graph. Very good. Again, the bracket means that negative 2.5 could be one of my answers. Okay, it could be. If I didn't have the bracket there, if I just had a parentheses, it wouldn't make much sense. Okay, what test do we use to test if something is a function or not? Guys, this is all being recorded, so if you miss anything, you're welcome to go back and look at the video, okay? I'll put it up about 10 minutes after we finish. The vertical line test, very good, John. So, John, would this graph be a function? Again, this is not here, sorry, that's not there.
Yeah.
It would, because anywhere you put a vertical line, there's only one intersection, one intersection, one intersection. Would this graph over here be a function?
No.
Right? And this is the easiest example. A circle clearly has more than one intersection, because it's a secant, isn't it now? Isn't that a secant line going through? Which has two intersections. So that is not a function. Okay, so we're good on that? Because they're going to ask you a question about that. You just have to know the vertical line test. Okay? Yes?
Can you do one with like inverse, like one function inverse?
Like how to find the other function from the inverse, or?
Like, it was one of the problems from the packet
That said, find the inverse of this and then prove that it's the inverse by doing g inverse of x. Okay. I'll do a quick one with those. So if you have, okay, let's say you have that and you want to find the inverse. How do you find the inverse of a function? What do you have to do?
You first just put right, y equals to x plus 5.
Okay, John, and keep going.
And you would switch the y to x. And x equals to y plus 5. Subtract both sides by 5.
We got to listen, guys. Talk a little louder, okay?
Subtract both sides by 5. And
But what did you do before that again?
you switch the y to x.
Why?
Because it's the inverse.
Good. The definition of an inverse is when x and y coordinates are switched. Therefore, when we get to this step right here, we then switch the x and y coordinates. And then,
Subtract both sides by 5.
good.
Divide by 2.
Okay, John, very good. Again, all you have to do is move the 5 over and then move the 3 over. So you're resolving for y. That is your inverse function. How do we write that? Of? Okay, not of -1. F -1 of x. Okay? So that would be the same thing. These are the same things written, okay? But you would write it as an inverse function. Now, Juliet, that follow-up problem, you're not going to need to work on. Okay? Remember that I said prove by doing the function composition and stuff? It's not on there. So I'm going to stop for that one just for the sake of time. We all know PEMDAS, right, guys? I know this is going to sound lame, but there's a PEMDAS problem on here. Okay? Not joking. Imagine you had a problem like this. A lot of people get this wrong, though, because they do the wrong order. Okay, PEMDAS. What do I do first? Any parentheses? You can, but there's a lot of room for error plugging it in. No, you definitely can, but there's a lot of room for error, Bridget. Like, for example, here, if you plug this in the calculator and you don't do parentheses correctly and stuff, it can come out wrong. So I would just be careful. Yes, 8 over 2 there. So parentheses is non-existent, right? Next is? So what does that become? After exponent, what do you do?
Multiplication.
Or,
Division.
which one?
Division first.
What is it, Vicky?
Subtraction.
Whichever one comes first. Remember, guys, this is what a lot of students forget. Take a look at PEMDAS. They're grouped in orders of 2. You do parentheses and exponents first, then you do multiplication and division. But this order just depends on which one comes first. So you just look from left to right. First thing I see is multiplication. What does this become?
32.
Then I see subtraction. Let it go, because we're not there yet. Then I see multiplication. What do I got?
10.
On the bottom, I see addition. Let it go. We're not there yet. We're still on multiplication division. Then what do I see?
4.
Good. So at this point, now you can go into addition and subtraction. Okay, so you always do it. Whenever you see addition and subtraction, let them go until the very end. Unless they're inside of parentheses, which you have to do first, because parentheses is first. Then you just do 26 over, what is that? 5. Okay, 5.2. Those are what your problems are going to look like. Okay, or you know what they'll do? They'll have it in lowest terms. But I just went over, if this is in lowest terms, obviously. But if it were a number like 26 over 4, let's assume the answer was 26 over 4. Oops, 26 over 4. We'd have to reduce by a factor of 2, giving us 13 over 2. Okay, so make sure you're in lowest terms for your answers. I know that sounds really basic, but there is a problem on this, so just keep that in mind. All right, what about this one, guys? We just did this. Logs.
I hate
I wanted to know what the log base 2 of 16 was, I can do this two ways. One way.
Log, 16.
Good. Everybody, go right to your calculator. Just type log 16 over log 2. Okay? That's called change of base formula. Change of base. That's one way. The other way to do this, believe it or not, is to do this. And this is actually quite simple. Watch what I'm going to do. I'm going to call this x. Okay? And then I'm going to say, let me convert this back to exponential. If I go back to exponential, it's 2 to the x equals 16. Well, what's x just by looking at this problem? 2 to what power gives you 16? What is it? 4. And if you do this, what do you get? Try this in your calculator. You're going to get 4 also. So either way, the answer is 4. You can do it by converting back to exponential and saying, well, 2 to the 4th is 16. Okay? Or I can just type these two in and get 4. Oh, I don't know. You had a question, I'll play. So again, you can do log 16 over log 2 like that and get 4, or convert to exponential and get 4. Either way is fine.
Did you put parentheses in?
Well, you need parentheses. They're going to automatically be there, I think. Right when you hit log, a parentheses should automatically open.
Parentheses closed.
Close it like that. You don't need the major ones around logs. Okay, you don't. If you want to be safe and put them around here, you can. But just so you know, you don't need them. That's not?
That's what it was.
Oh, the major ones. Yeah. Is the inverse of. What do you mean by inverse? Give me more.
It's like, it's from concept 10 to concept 15.
Like finding the inverse, yeah, it'd be like one of these. Remember the one we did over here when you found the inverse? You set this equal to y, switch x and y, and then solve for y again?
Well, like x like the negative one, then x.
That's what this is here, yeah. So when you find the inverse of a function f of x, you call it y first, switch x and y, and then solve for y, and that's called the inverse. Okay, so if they said like find the inverse function, you just have to be able to go through these steps. Okay? On the study guide, I'm not going to only because I already recorded the whole solution. I put videos up on Headline for those. There's 2 full videos that are of all the answers to the study guide. I went over all, so you'll see me talking and handwritten stuff, so it'll all be there. What about something like this? What about something like this?
Dots.
Okay, right away everybody thinks of dots, right in the bottom? I agree completely. But before I do that, I'm adding fractions, aren't I? When I add fractions, what do I need?
You have the same denominator, just add it.
Same denominator. Do I have the same denominator?
Yes.
So I'm good to go, right? So what should I do up top?
Just add it.
What's 2x going to combine with over here?
Negative x.
What's 2x and negative x?
X.
What's 4 and 1?
5.
All over? Now, you know what a lot of students do? They look and they say, oh, none of the answer choices make sense. That's not there. It shouldn't be there because, Rosie? Good, what do I got?
X plus 5.
So what do I do next, Rosie? What am I left with? Just x minus 5? 1 over x minus 5. That's another one of the common mistakes. Okay? Another choice, I guarantee you, your choices will be x minus 5 there somewhere. Because a lot of people forget the 1 over, okay? Remember, whenever you cancel something, you're left with a 1 behind. Let's see. If this had been a negative sign in the middle, what's the easy thing you should do that I always tell you guys? Good. Make it a positive, and then just make this a negative, and make this a positive. Okay? Always do that. I'm telling you now, it'll make it a lot easier on you. Make it a positive in the middle, make the others negative.
You don't have to do the same thing for the denominator.
No, that's the key. Again, it's always just the numerator, because a negative sign indicates that either the top or the bottom is negative. We are choosing to negate the top, so we can keep our denominators identical. Okay? Where's you had a question? See mine?
I said, why did you choose that one?
And not this one over here? because you're subtracting this quantity, which makes this quantity a negative idea. It'd be like saying, I have $10, right? And I'm losing $6. I make the 6 negative, right? Not the 10, because I have 10. Whatever you're losing becomes negative. Since we're subtracting this, we're losing this amount. So we have to make it negative, and the other one we leave it alone. Okay, what about this, guys? Factoring with AC method. So if you had a problem that said, trying to come up with one, hold on. Let's say it was 12x squared here, let me just make it easier. Alright, what about this problem here? Now, the problem does not say find the roots, so you can't just find the roots in your formula. And you can use the root formula, because you'll get the roots, but you won't get the factors. So?
Oh, you split it down the middle.
No, AC.
I mean, no, you AC method, yeah. You must find love now.
So you start with AC. What do you get?
36.
And what's B? Alright. That's my beginning. Again, why do I know this is AC method? Because there's a 12 here. There's not a 1 here. When there's a 1 here or a unity value, you can just factor. But when there's something that's non-unity or not 1 in the front here, you cannot just factor this. You got to use AC. Now what do I do, John, down the middle?
Teacher.
I'm not a T-chart yet. You guys are jumping the gun.
No, you were it. Oh no, first you have to find.
Well, I'm asking you, John, what am I going to write it at? That's my question for you. I know that's fine, but the middle has to be broken up, right? What numbers multiply to 36 and add up to 20? Come on, people.
18 and 2.
Thank you. 18 and 2. Again, break this into 18 times 2. Doesn't that add up to 20 also?
Yeah.
So make this 18x, make this a 2x. Okay, now, thank you, very good. Don't forget your signs, because if this were a negative 2x, it's very important that that's a negative there. Now factor by grouping. What comes out of here? 6x, good. A lot of people say 2x, because they see a 2. 2 comes out also, but 6 is bigger. What's left over? Okay, how do I remember that? In case anybody forgot, divide by the GCF you took out and see what's left over. And that's how you always do it. What comes out of here?
1.
Good, the 1 comes out. And that's why I picked this problem on purpose. Take a look. It looks like nothing comes out of here, right? But really, to have a 2x plus 3 here, there's really a 1 out in front. And what this does now is it allows me to write it as AC method. Because now I take these two components and write this as 6x plus 1. Had you not taken the 1 out, this part looks a little bit off, right? Without that 1 there, now it's just 6x. And now here you have 2x plus 3. Okay, whatever repeats itself goes on the bottom right there. Before I go into your question, another thing to do is this. If you forget, guys, these are multiple choice problems. So if I just show you real quick without seeing the actual problem, look at this problem up here. They give you the 4 factor choices, right? What could you just do? Yeah, just FOIL all 4 out, right? You could FOIL all of them out and see which one matches up. You could always do that if you forget AC method. Please. Yeah, you got it? So again, always use your choices to help you.
How many problems are on the class that go around?
I can just tell you exactly if you like. 25 multiple choice. 23 pre-response. 50 problems? It's not bad. Your tests for me normally have between what? 10 and 15 at least?
Or 100 probably.
I mean, no, normal tests I'm saying. My test of the year.
Oh, yeah.
This is a 2-hour exam now. It's a 2-hour test. Okay?
Last year,
I really, guys, it's just study. I really think you're going to be fine.
What about that thing? It's like, you have to like add, it's like, starts with an S, synthesis.
Synthetic
Yeah.
division and substitution and stuff? Okay.
Is that on there?
Is that? I don't think so.
You said no.
Okay. There's no. So synthetic.
Relax, relax, hold on.
It's basically like substitutes just like they think it's going to be able to do pretty much.
Okay, there is, listen, people. There is an example of dividing polynomials. Okay? So, there's an example of synthetic division on here that might be useful, so let's go into an example. I'm going to make a different one up, obviously. Let's say x to the fourth plus x cubed plus 2x minus 5 divided by x plus 1. Okay? If I had to divide these two things, I can't do this by hand. We didn't do long division, which is a waste of your time, by my opinion, just to be honest. So let's use synthetic. So for synthetic, what comes on the outside of the box now?
Put one.
A negative one.
Thank you. Guys, again, remember, on the outside, you're going to put a negative 1. Why are you putting a negative 1? It's the opposite of whatever this might be as a root. Along the top, who can tell me? Why is there a 0 there? What's missing? X squared. Where's the x squared? Well, it's right in here, but it's not there. Okay, so there's a 0. Now, you bring down the 1. Okay, the first, whatever's here comes down. Remember that, guys. Whatever's there comes down front. Negative 1 times 1. Negative 1 plus 0. 0. Negative 1 times 0. 0 plus 0. All right, looks good. Negative 1 times 0. 0 plus 2. Negative 1 times 2. Negative 2 minus 5. So your answer turns out to be, remember, 1 degree less. So this was x to the fourth. What is this going to be? Is there going to be anything here? So there's no x squared. There's no x term. And then there's a constant at the end here. What does the 7 have to do with again? What was that called? Yes, good. It's our remainder. Negative 7 over x plus 1. Again, remember, guys, there's nothing here. There's a 0x squared, and there's a 0x, and then there's a plus 2. And then your polynomial is kind of done here, and then you have your remainder that's left over. What if the remainder didn't exist? You just list the answer. So if this had been a 0, okay, you don't have a remainder then. And then your final answer would have just been x cubed plus 2.
You wouldn't put x plus 1 still?
No, because this would be 0, wouldn't it? What's 0 divided by 8? It's still 0, isn't it? So the x plus 1 has no effect on it at that point. So if the remainder doesn't exist, you just have the polynomial that's left over. But you have to remember your 0 placeholders. For the roots, you either use a synthetic table to check, or you can just go to your calculator and find the x-intercepts using the intercept function. Remember that? Because whenever you're asked to find roots of an equation, you could use the quadratic program if it's quadratic. If it's a cubic, you can just look at the graph and see where it crosses the x-axis and find the zeros. Remember on your calculator? Second, calculate. You press the 2 button and find the roots. It's where it crosses the x-axis. Left, guess, right, guess.
What about quadratic?
Quadratic formula? You should know it, but you can always use a root program. Okay? Let's see what else. Lines that are perpendicular. Okay, this was a tricky problem. Lines that are perpendicular. So let's say we have, and this is not something we emphasize very much, so I'm just going over it now, so to help. If you had y equals 3x plus 7, okay? So you had y equals 3x plus 7, and you knew that you wanted the equation of a line perpendicular to this line that goes to the point 2, 4. Again, I want the equation of a line perpendicular to this line that goes through the point 2, 4.
Y equals negative 1/3.
Okay, good, John. That's a good start. So John started by saying your answer is definitely negative 1/3 x. Absolutely. Plus what, though? That's the question. We call that b, right? How can I find the b value? Very good. So plug it in, guys. Again, just take these values, plug that in, plug that in. Okay, once you plug those in, you just solve for b. That's your y-intercept. So remember, lines that are parallel, so parallel lines have the same slope, right? But perpendicular lines have a negative reciprocal slope. And that's where John came up with what, John? Negative 1/3. Okay? Because he saw the 3. What's the reciprocal of 3? It's 1/3. What's the negative of 1/3? Just negative 1/3. That's the slope. There's the x. You need the b value, plug in the other point, you get the b value. So if you were given a multiple choice problem, right away, anything that didn't have a negative 1/3, what do you do to it? Yeah, cross it off. Okay? Anything without the negative 1/3, I would cross that off right away. Okay, I did an example of this on Thursday, but I'm just going to mention it. I'm not going to do it right now. You need to know how to find the vertex of a parabola. Okay, remember parabolas? Look like this. You need to be able to find the vertex. You can do it, yes. You can always do it in the calculator.
Even the max.
Max or the min, either one, depending on what it is. But you can always also say, well, the axis symmetry goes through the middle. The axis symmetry is negative b over 2a. Once you find the axis symmetry, you can plug that back into the function to find the coordinate. So say this turned out to be 4. That means your vertex is going to be 4 comma some number. Okay, remember the axis symmetry lines up on the vertex. If you can find the axis, you know that, and you can plug it in. What you could also do, as Rosie said, go to y equals, let's say it was x squared plus 2x minus 6. And I hit graph, come on, zoom 6. Okay, hit graph, and I want to find that vertex. Well, isn't it right here? See the vertex right there? You can use the min function. Second calculate, it's a min. Why is it a min?
Because it's down.
Because it's concave up. Because the graph is concave up, you have a min at the bottom. If the graph were concave down, you would have a max at the top. Okay, so we're using the min here, number 3, because it's the bottom. Left bound means I go to the left of it, enter. Right bound, go to the right of it, enter. Guess, somewhere in between. Okay, if your right bound and left bound are not correct, you're not going to get an answer. So there's your coordinate, negative 1, negative 7. A lot of these problems you can answer just using a calculator. That's why the test is really not that hard. Okay, a lot of it you can check by hand, and personally, because I've studied this enough, I would just do it all by hand because I'm just going through it. I would probably check with my calculator, but you can also do a lot of these strictly on your calculator. What about this one? And this is one that we did. We talked about a minute ago, but we did it with imaginary numbers. If you had, let's say, 4 over 2 minus radical 5, and it said, which of the following is this equivalent to? And gave you a bunch of multiple choice. How do you get rid of that radical in the bottom? What do you have to multiply this by?
It makes 2 plus radical 5.
Good. Not just radical 5, because you said radical 5 first. Over. Very good. Okay? It's the exact same thing as this, but it's the opposite value, which is called the binomial conjugate. Remember that this is one of the 2 binomials, this is the other. Together, they make up 2 plus or minus radical 5. These are conjugates. So anyway, we multiply through. Why do we use this technique? We're not adding or subtracting. Yeah, and remember I told you that's not even true really though? Once you get the pre-calc in calculus, is that what you said? Sorry. Once you get the pre-calc in calculus, you're going to learn that a radical on the bottom really doesn't matter. You can have it in there. It's a good technique to know because you're going to use it though. You're going to use it as something called limits later on. But the idea is that when you FOIL the bottom out, what happens? The middle terms cancel. FOIL the bottom, put parentheses around it. First, you get 2 times 2, which is inner is going to, or outer rather, is going to be 2 radical 5. Inner is going to be negative 2 radical 5. What's going to happen to them? They drop off. So even though you have 2 root 5 and minus 2 root 5, these 2 root 5s cancel in the middle. What's left when you multiply root 5 by root 5? With a negative sign though, because again, there's a negative here. So I end up at the top with 8 plus 4 root 5, but look at the bottom now. What is 4 minus radical 25? What is it? 2. 4 minus minus 5. This is just 5, guys. 5, guys. Nobody? Come on, team. 4 minus 5 is just negative 1. Okay? So again, radical 25 is just 5. 4 minus 5 is negative 1. 8 plus 4 root 5 over negative 1. Well, that's not going to be a choice. Why is that not going to be a choice? Yeah, see the 1 down there? Can't I just move it to both tops? Make a negative 8 minus 4 root 5, and that will probably be your choice. Okay? So the problems aren't tough, it's just simplifying.
So you can just remove the bottom.
Remember, whenever you have a monomial, you can divide it into both parts of the binomial or trinomial or whatever polynomial is up top. When this is a monomial, one term. So if I divide negative 1 into 8, it's negative 8. If I divide the negative 1 into the 4, it's negative 4. Remember, this is on the inside. Inside, this is considered to be on the outside. The outsides can work with each other, the insides cannot. Okay? Like feet to yards and yards to feet, all that stuff?
I was gonna ask you about that.
Let's see. Relax.
Who's still growing?
Let's
We
do the
did
outside.
like the.
He did that.
No.
It's not.
Oh, thank God.
All right, next. Yes.
Like law of signs.
No. There is no trig on the test at all, actually. It's just algebra 2, yeah. There's no trig at all.
Mr. Harold?
Yeah.
Is there gonna be like you know the problem, you know, like the ER, like you have like the ERT.
ART.
Exponential growth and decay?
Yeah.
Yes, and we'll get into those when we see them.
Aren't
Yeah.
you quizzing us on that? Did you say that's?
Yeah, you said you were gonna get.
Yeah, whatever's on there I'm going to use as a grade. I have to look back at it again. Give me a sec, guys. Hold on. Let me put up a problem, then we'll go over that. But that's what I'm going to use for your actual assessment for that. How do I solve a problem like this? How do I solve for x in this kind of problem?
Don't you like split it? So.
Why? You're right. Why? Means what? Good. The inside can be negative or positive. No matter what, you're going to get a positive on the outside, right? So, this quantity you see inside the bars, this could be positive or it could be negative technically. So what you have to do is this. That's it. And then solve separately. Okay? Bring the 4 up, add the 3, so you're going to get 31 here. Bring the 4 up, you're going to add the 3 on that side, you're going to get negative 25. Okay, so you have 2 answers, obviously. 2 answers, because absolute value.
I thought it was the minus beta, that's where it's switched from the answer.
No, the answer does. If you're going to switch this side, you need to negate both terms at the top. So the way I teach it is to say, just negate whatever's on the outside over there. Makes it a lot easier. Make the negative of. So if you negate 7, you get negative 7, negate. What if you what?
If you negate negative 7.
Positive 7, yep. What about these problems? We've done these before many times. Something like that. It's solving, but it's a radical. So how do you get rid of stuff first? What do you do first? Good. Subtract the 1, you get 11. Divide by 3. Square both sides. Subtract the 2. Come on, you know that one. Okay? And then you can write it as common denominator.
You got the award.
So how old was Jacob? Then I got the award for taking my calculator.
Did you really?
It's she honorarily.
She does awards in your class?
Yeah.
That's funny.
I got the turn it around award.
No.
Turn around award meeting. Anyway, you guys get this idea? Now, if you forgot, listen, if you forgot and it's a multiple choice, you could technically just plug in the 4 choices for x and see which one works.
Can't you actually simplify?
Right? And we could, absolutely. So I would write this as 18 over 18 over 9 and 121 over 9 and then subtract those 2,
How
yep?
do you get 18?
Because I want a common denominator of 9, right? What's 18 divided by 9, Julia? Isn't it 2?
Yeah.
That's the 2 there. So I'm writing with a common denominator. Multiply top and bottom by 9. 9 and 9. And then subtract.
Never mind. That's not the-
103 over 9 cannot be simplified further than that. So it's a decimal. How did I get 121? I squared both sides. Sorry, I didn't show that. To get rid of a radical, you got to square. So it means you got to square here. 11 squared is 121. 3 squared is 9. Okay? All right. What to do here?
Oh, break the radicals.
Sorry?
Break the radicals.
Thank you. We got to simplify. You cannot, by any means, start to subtract. Got to break them down. John, first one.
Pass.
Let me do it.
Pass.
Let me do it.
First one?
Like,
Let me do it.
25 and 3. It should be automatic, John. Come on. You know that, right?
I know, right?
Jay, middle one.
Oh.
Use this one to help you.
1, 6.
Use this one to help you.
12. And 4. No.
What do you see here? See that 3?
24.
Since there's a 3, there's a chance the 3 will show up here.
Okay.
16 times 3, and 16 is your perfect square. Okay? Leone, last one. 27.
9 and 3.
Very good. 9 and 3. Again, he sees the 3, and then he said, oh, well, that's a perfect square. It happens to be. Works out that way. I made it that way. Now, root 25 is? So this just becomes 15, root 3. Because this is really a 5. This is going to be? Good. 4, which makes that 8 root 3. This is really what? Which makes that 15 root 3. Well, 15 root 3 and 15 root 3 gives you how many root 3s? 30. And then 30 minus 8 is? So 22 root 3. Okay, remember, the roots are like variables. If you had 15x minus 8x plus 15x, you get 22x. Treat them the same way. All right, very, very, don't take this the wrong way, pointless problem, but something you should know. Okay? Pointless. So, if you had the graph of y equals x squared minus 12, okay? And it said, what is the range of this graph? Not domain, range. What is the range of this graph? What does this graph look like? Who can tell me?
Straight line.
No, absolutely not. It's x squared, Jay. X squared.
Oh.
It's a parabola. It's a parabola. Okay, be careful. What does the negative 12 do to the parabola? This is the normal parent function for a parabola. What does the negative 12 do? It brings it down? In what way? Is what?
It's like a shift.
It's a shift down. Very good. It's not a reflection, Rosie. Be careful. When you go like this, it means that there's a negative in front of here. This negative 12 means like this, right? So take a look now, guys. The range is the y values, right? Well, the y values start at negative 12 and go all the way up to infinity. So what would the range be? The range would be y is greater than or equal to 12. That's all the ranges. Okay? Or you could say, I'm sorry, negative 12. Or you could say negative 12 to infinity. Okay? Again, think about the picture of the graph. If you didn't know in your head, what could you just do? How could you find out what this looks like if you didn't know what it looked like? Yeah, just type in your calculator. X squared minus 12. Type in the calculator, you're going to get this. And then if you want to find the range of something like this, you just say, well, it starts at negative 12, and it goes up to positive infinity. Either this choice or this choice. All right, imaginary numbers. Adding and subtracting imaginary numbers. Not multiplying, or dividing, just adding and subtracting. What do you do? Good. Plus, make this, and now? Yeah. 2 and negative 3? Negative 1, 4 and 5?
That's it.
No, watch the way to test that.
John.
What should be like a triangle?
You should know that I squared is negative 1. That's what we were talking about before you came in. Okay? That's what he's asking about. You should know that I squared is negative 1. I mean, it's only when you ever, because I by itself is just I. I to the 0 is automatically 1 because anything to the 0 is 1. The I cubed is not really coming to play.
I cubed negative 1, right?
Say again?
I cubed is negative 1.
I cubed is negative 1, absolutely. Remember we did difference in sum of squares where we had x cubed minus 27 like that, and you had to use the formula to factor this like that? Anybody remember this or not?
No.
I don't know, maybe
Just
so.
put X out.
Okay, we had like this, we had, and then we wrote that whole formula where we can factor it. It's like A plus B. Yes, yes. So it was, if you remember,
Poor guy.
Okay,
Remember-
so you had,
after Rosie, after.
No,
Oh, yeah.
No, that's why I'm putting it on the board. I think I'm correct with that. It should be correct. Okay?
Yeah.
This is the formula that we use to factor. Okay, where we said like, okay, this is cubed. So you know, like this would be just x minus 3, because 3 is the cube root, and this would be x squared plus 3x plus 9. Okay, this is where we identify A and B.
oh wait, no.
Where? Sorry. No, it's right. Again, remember here's what we did last time, guys. We identified A. We said, well, A is equal to x because it's cubed, and B was equal to 3 because it's the cube. And then we just take the x and the 3 and plug them in for A and B wherever we see they go. And whenever you see a minus, you use the bottom 3, like that. When you see a plus, you're going to use the top ones, like that. Now, another way to do these problems, though, okay, another simple way to look at these problems is to say to yourself, well, I can actually graph, you know what, I'm not going to go into that. It's going to be something to learn completely differently. Yeah. Remember that whatever sign you see here between the cubes will always appear there. So if you saw a plus sign here, rule that out right away. Okay, rule that out right away. And then go into that. This is a formula you might want to memorize, because I didn't know it was going to be on your test as a question. And I gave you the formula, they're not giving you the formula. What else can you remember, guys? Here's a quick little trick. If this is a plus, this is A. If this is a minus, this is A. So when you look at your answer choices, if you start with a minus here, you know this is going to be a minus and this has got to be a plus. So if you saw a minus and a minus here, you would roll it out right away. So you don't even have to memorize the formula if you know these tricks. You know that you're going to have the opposite signs there. It makes it a little bit easier for you. Please? Some of the difference of cubes is just good to know. It doesn't show up that much. It could show up in calculus when you're factoring something, but at that point in time, you'll have done so much of it that you'll know it by then for sure. Yeah, I mean, you can always write a program with the formula in your calculator. You know, you're always welcome to write your own programs with notes. Nobody's going to stop you from doing that.
You know what teachers next year?
I really don't. And again, I wish I knew because I wish they were picked already. Keep going, keep going.
You have
Next.
to learn more about this Dr. Chung after class.
Not now.
After session, I mean.
Like, what did it do?
Now, if we had something like the following. Guys, we're almost done. Come on.
You just got around.
Let's say it is.
It's like,
Oh, yeah, I remember that.
that was weird. I thought you
What was that? And so did I.
fired.
I don't know. I just like heard a weird noise.
I can't say oh,
Are you Muslim now?
I forgot he still Jewish, right?
Oh, this
They
is
do
what
say
they
Jehovah, they don't say Allah.
They do say
They say Jehovah.
They say Jehovah.
Who says Allah?
Muslims say Allah.
Enough. Let's go. Back to here. For this problem, what do I do?
Don't you?
Oh, you can.
Like,
For what? Oh,
It says simplify completely.
Can't you get rid of the square, the fours?
You take out the
And
first
square
square,
it's like, the X, it becomes back. Yeah.
Yeah, I can reduce some stuff, but before I do that, guys,
you combine,
let's combine it, right? What's 12 times 2?
24,
What's x to the 4th times x to the 2nd?
6,
Y to the 4th, y to the negative 1.
3.
And now we can start doing stuff. Good. So, what's the perfect square that comes out of 24?
And
Perfect square.
4. Good. Again, break up the 24 and do a 4 over here and a 6 over here. Remember how we did this? Perfect squares over here, non-perfect squares over here. Next, 6. Can 6 be divided by whatever the index is here? What's the index here?
2.
There's a 2 here, isn't there?
Yeah.
So 6 can be divided by that, can it?
Yeah.
So let's put the whole thing over here. But the 3 can't be. How many of the y should I put over here?
2.
And then how many are left?
1.
1,
Okay, and now I can reduce. I know that square root of 4 is
2,
6 divided by this little 2 that's really here is 2 divided by 2 times. Okay, that's your answer for this kind of problem. Rosie.
It's hey. I forgot. I already forgot.
Okay. Don't think about it. We'll come back to it.
Huh?
That's what I got.
What? When are you ready? For what? Oh. What? Wait, what?
All right. How about this kind of a problem?
You get common denominator.
None?
So would you multiply by 4 in the middle and then 8 on the side and 8 on the
Close. Close. Make it easier, Juliet.
Yeah, you need common denominator.
Yeah. Multiply them by 2, guys. Multiply by 2 here and here. A 2 here and here to get them all to be 8s. You could do 8 and 4 everywhere, but then it's just going to have to reduce later. So, multiply by 2 over 2. Multiply by 2 over 2. Now look at all your denominators. What are they all?
8.
So you can automatically do this, remember? And now you're left with 10x plus 2, because you have to remember there's a parentheses here, minus 2x minus 5, with the parentheses again, equal 10. Again, don't forget, you have to distribute that 2. You have to remember that this really has a parentheses around it. And now solve the equation. Okay, I'm not going to go through the rest of it.
Jason, you back.
Before you two leave, there's one graph of a quadratic on here. Remember I said you're not going to have to graph much? There's one graph of quadratic, I just saw. I didn't know it was there.
Is it the one that you showed us earlier?
It's just graphing quadratic. So remember, like, either quadratic could be written like this, like that. A quadratic could be written like this, or a quadratic could be written like this, with a number in front. Okay, so you have to be able to graph. I'm not going to tell you which one. You have to be able to graph one of those. Okay, if you ever given these and you forget how to graph them, you could just FOIL it out and get back to this. Okay, you could always use your calculator to help you.
Hey, that's what I do. Listen out. Do we have to know how to graph? That's what I was gonna ask.
Conic sections? No.
So there's no conic sections at all?
No.
Why I like that? I'm so happy.
Jason's Jewish. Huh? Jason what?
Let's see what else.
Yeah, Jewish.
I can still picture him, man. I can actually picture
Really
him.
Jewish?
He's so temple reading his
All right, here's a question for you guys. What if you had a cubic equation okay, and it said to factor? There's 2 ways to do this, and we've learned both ways. How can I try and factor this? Grouping. Grouping is one way. That's the first thing I would think about. And synthetic. Very good. Synthetic will give you the roots, though, remember? And then you got to take the negative to get the factors. So by grouping, I see that there's an x that can come out here and squared. I'm left with 2x plus 1. Here I can take out a negative 2, or negative 9 rather, sorry. I'm left with 2x plus 1. And what do you notice? 2x plus 1 repeats itself. So you're left with x squared minus 9, 2x plus 1. Which looks like you're done. But, what do you got? Well, no, we're just factoring. No roots, just factoring. What do you got here?
X plus 3, X minus 1.
Okay? Now, had you done synthetic, your only answers that would have worked would have been 3 or negative 3, because this turned out to be a decimal, right? You saw it? The root of this would be negative 1/2. Again, if you made a t-chart, you set this equal to 0, you move the 1 over and divide by 2. So this will not help you. So if you did synthetic and you tried 3 through the table, just to prove it, okay? Yes, you can always do that, but that, again, the calculator will show you where across the x-axis, which are the roots, which will tell you 3 or negative 3, and then you can find. Yes, absolutely. Oh, yeah. But again, this is not asking for the roots. This is only asking for the factor. So the calculator will give you a root of negative 0.5. It doesn't always know that this is a factor, because watch, Luis, what if I had this? And you want to find the root from that factor. Wouldn't the root still be negative 1/2? Now, aren't these both giving you roots of negative 1/2, but they're different factors? So when you're factoring, you got to be careful. You can't assume the root always works. So the 2 comes down, 6 and 1 is 7, 21 minus 18 is 3, 9 and 9 is 0. Take a look at what's left now. This becomes 2x squared plus 7x minus 3. Okay, so one of your factors is definitely x minus 3, because that comes from right here. And where do the other two factors come in? Here and here. That's what that factors into. So personally, synthetic table works, but grouping is easier for a problem like this. Okay, because you don't have to worry about factoring now this with an AC method problem. Okay?
What about, you know, when you have like a 1 and then you have to go back and divide the 1 again? We're going to have a problem like that. It's like a dot, but then you have like x, then you have like, you have to go down again and do the dot.
Anybody?
But dot.
It's on our
You
phrases.
know the one that has like a 1 at the end of it and then you have to go back again?
Well, I think that's the one I was asking you about, the deleted range.
When you do it something,
No, when you do like the dots, but then you get a 1 and then you have to go back in again. It's like x, you get a value of x plus 1, x minus 1, and then you have to go back in again and combine it and do the dot.
what are you looking for?
What
Yeah, I don't know what you're asking. That's why I'm
It's
trying
kind of like, it's, basically then you have the dots, but like, I'm just asking if you're gonna have a problem.
to. With dots,
Yeah.
you should know dots, yeah, if that's what you're asking.
Oh, you mean DOTS?
Yeah, the one that has
Oh,
like,
what do you mean? Okay.
This is dots here, right here.
no, I meant the one that has the 1 on it.
What one? What was the one?
It's like, you know the one that has like x plus 1?
Like something like the inverse, like a negative one.
No.
You know the concept?
You gotta rephrase it. Think about it another way, because I don't think I'm the only one not getting that.
No, it's part of the dot.
All right, here's a problem that we didn't go over this year, but it's very easy to do. Okay? If it says solve this and graph, okay, solve this and graph, how would you solve this? We did, those are bars.
So x plus 8 is greater than 4, 2x plus 8 is greater than negative 4.
Be careful, John, you're making a mistake. We did this in class. It's less than negative 4. Remember, when you put the negative, you have to flip that sign. Okay, be careful there. So here, what does this become? Solve
Minus 8.
it. Thank you. Over here, negative 6. Okay? So, if I were to, you just did it in his head. Subtract 8, you get negative 4. Negative 4 divided by 2 is negative 2. Subtract 8 from here, you get negative 12. Then divide by 2, negative 12 divided by 2 is negative 6. Do it up here. Don't do it on hand. You guys, everybody here can do this for sure. At this point in time, what are numbers that are bigger than negative 2 but less than 6? How would you graph this? And by the way, when they say graph a solution of this, they mean graph on a number line, obviously, because it's not a function.
Oh.
Okay, it's not y equals, so you can't graph on a graph. What's less than, or what's greater than negative 2? If I put 0 right here, where's negative 2?
All the way that way.
All the way?
No, just like, you shift them.
Thank you. A little bit, maybe. Okay, where's negative 6? What's less than negative 6 mean?
Closer to 0.
Is it negative?
I'm talking about the 6 I said first.
Oh.
All the way to? So everything less than negative 6 is this way. What's everything greater than negative 2?
That other way.
So we have a solution that has no overlapping set. Part of the solution is here, the other part of the solution is here. This you did in algebra 1. Okay, it's the top of it, you definitely covered graphing down a number line. Now, if it's less than, I put open circle, open circle. What if it had been like this? Yes, you would shade each circle. Okay?
So that would have no answer.
Say again?
That would be no answer.
This is actually the answer would be or. Or. If it overlaps, if they happen to be going in the same direction toward each other and there's an overlap, it's an and statement. But that part's really not even as important. It's important that you can graph on the number line for
We're
now.
gonna have ones that they're like shaded, like concept 61.
You need to tell me what it's about. I don't know.
61. Yeah, that one.
On the area of the shaded region?
We're gonna have a new.
I mean, you have a problem with area on here for sure. So how about this? I'll give you an example. If you knew that the perimeter of rectangle A is 20 and the length is x plus 1 and the width is x plus 3. Find the area. This is a very good problem to think about. Perimeter of rectangle A is 20, and the length is x plus 1, and the width is x plus 3. Find the area. Well, why don't you start with the picture, guys? Right? Perimeter means what? The distance around. The distance around, and it's 20, right? Well, what is the length?
X plus 1 plus 1.
And what's the width?
X plus 3.
Again, these are never drawn to scale, guys, because the width is usually smaller than the length. It doesn't matter. They're just names. How do I find the perimeter of a rectangle? Add them all up. Perimeter, perimeter, perimeter. Because, think about this, guys. Here, if I wanted to find the area, it's the length times the width, or the width times length. But I can't do that. I don't have numbers, right? So I got to use my fact that it's 20 to solve this. So I got x plus 1 plus x plus 1 plus x plus 3. I don't want to write all that, right? So how many x's am I going to have total? How many numbers? 8. Okay, again. 3 is 6, 1 and 1 is 8. Solve, what do you get?
3.
Okay, so x is 3. You know how many people stop there and they say 3 is my answer? Circle the multiple choice answer says 3. That's great. But what does it ask for? The area. So now if this is 3, that makes this length what?
4.
And it makes this length? 4 times 6 is?
24.
The area is 24. Okay, remember, area is length times width. So you have to use some knowledge of geometry in here, which should be basic, especially with area formula for rectangle.
We're not going to have permutation and combination.
No.
Here.
Don't thank me. You would have been on my test, so you shouldn't be thanking me, I guess, right? Do we remember, people, how to do something like this? Besides putting in the calculator, just getting the answer? If it said rewrite in radical form and then evaluate.
Switch it to, what is it, size of
2
square root of
square root of
16
3.
squared. Cube.
Square root of 16 is? 4 cubed is? Thank you. Come on, these gotta be, cubes gotta be known. You gotta know cubes. At least through 5.
We don't really use them.
Okay? You're gonna though. I told you when we learned this, you're gonna use it in calculus. Cubes a lot. 1, 8, 27, 64, 125. 6 cubed is 216, but you don't really need that one much. 7 cubed, 343, but again, not needed. No 1 through 5. Okay, how about this one? If I gave you a function and told you that the function looked like the following. Okay, and it was a function of h, where h is the height. And the problem said the following. Determine when the projectile will hit the ground. What is the height when a projectile hits the ground? 0. Right? Think about it. Again, the object is launched, it hits the ground when it's at height of 0. So how would you find when the time when it struck the ground?
Log t, log 0 to t.
Not for time.
For h.
For h of t, you got to put a 0 in. Be careful there. If you plug in a 0 for t, it's finding the initial height of the function. Plug a 0 in for t, you get negative 12, don't you?
Yeah.
Okay, which means it was launched from below ground. That's what that means. Okay? So for this kind of a problem, you got to set it equal to 0 and then factor and solve, or just find the roots on your calculator. Negative 8, 2, negative 12 as A, B, and C. Find the roots, you know the times. Okay? Whenever you do part 2s, guys, if you use your calculator, you need to indicate that on there. Okay, so like for example, if you're going to use a root function on the calculator, just say, by determining the roots in the calculator, the times are x and y, or whatever you make it. Okay, with appropriate units.
That's gonna be enough.
Yeah, first of all.
So just write down the response, and if we get it right, we should get full marks for that.
Yeah, I mean, like, you would obviously have to set it equal to 0 to show that first. That's the first step. And then say, I use my calculator to find the roots. The times are 2.1 seconds and 7.8 seconds. And whatever units, minutes, whatever they're giving in the problem. Same units. Yes, always. Take out a 2. Oh, make it a lot easier on you.
Well, I get that. You go, he's got it.
Remember matrix problems with the examples like a person goes to the store and buys 3 burgers and 2 fries for $5, and then the other person goes in and buys 8 burgers and 12 fries for $12?
What did you say?
Some doggers. Do you remember those problems?
Yeah, and
You set it up like 2x plus 3y equals 8, 3x plus 5y equals 7, and then you solve the system matrix?
Yeah.
That's part 2 for sure. Okay, so know how to do that. Word problems with matrices.
second reading.
Okay, word problems, concept 26 through 29. Word problems with matrices.
Why is everybody learning today?
You missed the movie.
Oh.
Oh, you were there too. No, there, John is.
What about concept 1? Concept 1. You know any number is rational, irrational, real, non-real, know all that stuff.
Seriously, you saving
If you, guys, this is really basic, but I want to make sure we're clear. If you were given 0.3, -5, 2 pi, root 8, okay, as your 4 numbers, and it said graph these on a number line in order from least to greatest. Okay, what's the easiest thing to do for these? No, which is the smallest? Which is the smallest right away? -5. Okay, then you say 0.3, but you don't necessarily know that. Well, you kind of do know that. Okay, 2 pi is approximately what? Approximate. Double 3.14? 6.28, right? Just double the numbers. So this is around 6.28. This is around what? What's the square root of 8? Around? 2 point what? Estimate.
2.8.
Something like that, that's fine. Because square root of 9 is 3, right? So it's got to be less than 3. So whenever you're doing something like this, make sure you just look at all your decimal values. It comes up as a question. I don't know why, but it's on there. Okay? Okay? So if you have to graph those, and then if you have to call them rational or irrational and stuff like that, 0.3 is rational, and it is real or imaginary? Real.
Rational, real.
Is this an integer?
No, yes.
It is. It is an integer. Is it a whole number though?
No.
No, whole number is only positive. What is this?
Irrational.
Irrational. Good. Pi is irrational. What is this?
Irrational.
Also irrational, because if you break it down, it's 4 and 2, right? Which becomes 2 root 2. You still have a radical, thus it's still negative is where it's imaginary.
Oh, okay.
Okay? The
You do like real something and repeat it.
discriminant. Discriminant. B squared minus 4ac.
Can you give an example of the discriminant again?
Oh,
Sure.
wasn't that these?
Don't you use that in another, like, wasn't that in 2 different things?
Yes, that was also in conic sections. But that was capital B minus B squared minus capital 4ac.
These square
But they're different. Remember that? A, B, and C, E, G, F, the conic sections.
Oh, yeah.
Okay.
What's the beginning? Is it like a?
Negative B plus or minus square. You can do the rest. Okay, what about this equation? For this equation, if it says find the discriminant, what do you have to start by doing?
Move the 5 over.
Good. What's the discriminant, Juliet?
3 squared.
Negative 3 squared.
Yeah, minus 4, 2, 5. Negative 5.
Thank you. Negative, negative makes that A.
Positive.
4 times 2 is?
8,
Times 5?
40,
40 plus 9?
49.
Okay. So the discriminant is positive, isn't it?
Yeah.
And it's a perfect square. So what kind of roots am I going to have?
Real.
Double.
Real and rational. Okay, and they're distinct as well.
Okay.
If it's negative, then you get
Imaginary.
oh.
If it's 0, they're repeated.
You don't know the other one?
That's it.
No, I mean like.
There's 3 main cases.
No, I mean like 0. It's not just repeated. There's other words.
Repeated, real, rational.
Yeah, that's what I meant.
Sure, but they're just repeated also. It's the only major difference between the two we just did there. What about this? Or let me emphasize this. If you guys see this, okay, if you're given f of x, I know it's a weird notation I haven't seen in forever. It's not really useful. But if you're given f of x and g of x, and it says find f minus g of x, You're literally just subtracting f and g. Okay, so if you're given like this, okay? If you're given that and that's the problem, it says find that, you just do 4 minus 3 is 1x. 1 minus negative 5 is really positive, so plus 6, that'd be your answer.
Really positive, oh, because of the.
Yeah, because it's 1 minus negative 5, or 1 plus. Yes, compositions? Yes, absolutely. I went over that one in the beginning before you got here. It's in the beginning of the video. What about something like this? We got like 2 more to go and we're done. What about... And it says solve for x. Just use order of operations. Go.
Subtract A.
Good. I should really, whoops, that's just to make, oh, you know what, no, screw it. Forget it, let's do this one.
Divide by 5.
Good.
Square root.
Now 8 over 5, you get 1.6, but it's going to be negative 1.6. Okay, so when we take a square root, it's going to be a square root of negative 1.6. That equals x minus 2, then what do I do the 2?
Move it over.
Now, what do I have to put in front of here?
Plus or minus.
Good, plus or minus, because we're getting 2 answers here. So when I add the 2 over, it's going to be 2 plus or minus.
Negative. Oh yeah.
Okay? Again, taking this 2, move it over as a positive, put it in front of the plus or minus, and then instead of making that a negative 1.6, make it a positive, put the I outside of it.
Do you think that kind of answer was it like a solve in terms of like of I or something? Like,
No, they would just say solve for x. So you're saying could it be either one?
Yeah.
Sure, technically, yeah. Either answer is acceptable. If it said in terms of I, they wouldn't say that because then it would automatically give away the fact that it's going to be imaginary. You know? Dividing by a fraction, you multiply by the reciprocal. Okay? So remember when we multiplied and divided fractions, the easiest thing to do is to factor and then just start cross-canceling stuff wherever you can cancel. Not going to go over a problem with that.
can you do it with one that's like an actual fraction and then non-negative?
A fraction over a fraction? There's no complex fractions on here. What about this? Solve for x. What did I tell you guys recently? Very good. Whenever there's a variable in the exponent that triggers in your head, convert to logs. Give me the conversion for logs.
Is it log 3?
Log base 3, you mean, right? Of 17. Very good. How do I get rid of the 4? Really? The 4?
Oh, sorry, my bad.
It's being added right now. You subtract.
What do you subtract?
From whatever this turns out to be. You can plug in a calculator, can't you? Okay, log base 3 of 17 will give you a number. The number is going to be 2.4, I guess, minus 4. Subtract them. Try it. Last one. This is something we didn't do this year. It's not hard, and everybody's going to freak out tomorrow, and I know it's going to happen already, but if they're watching the video later today, hopefully they'll see it. If you guys can encourage people to watch this today, and going through simple questions from the test, but they're just different numbers, it might be useful for a lot of people that aren't here. And the people that aren't here are the ones that probably should be here, actually. You know what I'm saying?
Playing video games.
Yeah, so if you want to encourage people, it might be useful. What about something like this?
Your mom's playing video games Batman.
Trayvon doesn't even study. He never studies. It's really the
No easy substitution.
Okay, what if it gave you this, and it said, graph these and graph the solution set? Okay, it's no different than graphing lines. Let me start by saying that. So each time you could just solve for y, okay, and graph the line, or solve or find the roots and plot the two roots, the x and y intercept, and then graph the line like that. You can do it that way. It's the next part, which is like shading in a certain region that makes it tough. And you did this in Algebra 1, or you should have done it. That's why I didn't really go into it, but we'll go into it anyway. If I wanted to graph the upper one, I could find the x and y intercept. So I could find the x-intercept by setting y equal to 0. I can find the y-intercept by setting x equal to 0. I can do that, and then just graph the x and y intercept and connect and make a line. Or I can just solve for y and graph. Okay? So what I'm going to do on the side here is graph them. So solving this for y, I'm going to move the y over. Everybody see this? And move the 4 over. Does that make sense so far, what I just did there? Just flip-flop the spots. So y is less than this quantity. Well, just graph this as if it's equal to. So negative 4 is down here. And the slope is 2. Up 2 over 1. Up 2 over 1. Okay, there's the first one. That's my solution set. Now, here's the thing. If it were less than or equal to, like that, it would look like what I just drew. When it's not, anybody know what to do there? Do you remember this from Algebra 1? Yeah, it's a dash line. Very good. So here, I'm going to put a dash line instead, just so we're clear on that. These are really called open circles, not that that matters that much. Okay, that's my first line. Second line here, solve for y.
Plus 5. X plus 5.
Okay, but then that's going to give you a negative y, isn't it? You don't want a negative y, you want a positive y. So what's an easier way to do this? Is an easier way? Yeah, just subtract the x. Right? Move the x over. But now, be careful. Your slope is negative 1, your y-intercept is 5. See that difference there? Again, slope is negative 1. The x, mx plus b, or ax plus b is reversed. So 5 is up here. And negative 1 slope means go down 1 over 1, down 1 over 1. So I'm going to go all the way up to 5 out here. So 1, 2, 3, 4, 5. Okay, that would be that line right there. Now, notice, they intersect, right? They intersect where they're equal to each other, that's fine. But we need to figure out what the solution set is. So we need to test points to see which ones satisfy the original equations. So I go back to the original equations. Okay, go back to the original. Pick a point. Pick a point in each of the 4 sectors. You know, this has been split into 4 sectors now. What's the point here? 0. Isn't that an easy point to plug in? Plug in a 0 up here for x and y. What do you get? When you plug in a 0, the top one, focus. 0. Is 0 greater than 4? No. So this is not your answer region. Next, plug in a point from this region up here. And make sure you pick carefully. So this is 2, and let's say 5, right? That's this point right up here. So I'm going to pick a random point right here, 2, 5. So I plug in a 2 for x and a 5 for y. When I plug in a 2 for x, what do I get? Minus 5 is? Is negative 1 bigger than 4? So this is also not a region. So these regions are out. You're done with those 2. You see what I'm saying right now? Here, this is 3, isn't it? And I go down here, that's maybe like negative 1. So 3, negative 1. Or I could just put 3, 0, because it's probably even easier. Right? 3 zeros right there, but whatever. So 3 for x gives me 6. 6 minus 0 is 6. Is that greater than 4?
Yeah.
So that's a possibility, but I got to check the other equation now. Now plug in a 3 and 0 here. 3 plus 0 is?
3.
Is 3 less than 5?
Yeah.
So this turns out to be your answer region.
So would that be like a free response if you get
Free response. One of the free responses is asking you to graph them and graph the solution set. Okay? The solution set is where they intersect. And if you try to point over here, like let's say 6, 3 over here, 6, 3 will probably satisfy this one. Because you'll get 12 minus 3 is greater than 4. That's good. But 6, 3 probably will not satisfy this. What's 6 plus 3? Is 9 less than 5?
No.
That's why this region over here on the far right also doesn't work.
Because when you say ask to graph the solution set,
You graph the lines normally, then you look to see which region works, and then shade in that region. Okay? If the lines had been solid, it would have been because it was greater than or equal to, or less than or equal to up there. You could have a mix, by the way. You could have done this. Look, you could have that as less than or equal, then this one is solid, and the other one is just that. All it means is this. Right now, my solution set is in this region, and it could be on the line here, but it can't be on the line here, the dash line. Again, the dashed line is an open circle. Remember open circles with domain and range? They're not included in the answer. This is like a bunch of open circles all next to each other. This is a bunch of closed circles all next to each other. So this is part of the solution set over here, whereas this region right here is not part of the solution set. The shaded part is definitely part of the solution set. Okay? How long was that? Not bad, hour and 40 minutes.
Not